Assalamu alaikum, welcome to my YouTube channel. The topic is data bus and address bus and the registration. The data bus definition: on the system bus, 32 or 64 lines are reserved to transfer data from one computer to the other. These lines are commonly known as the data bus. A 64 line data bus can transfer 64 bits of data similarity, so it is not difficult. So see that the width of the data bus has a direct impact on the performance of the computer. Address bus: as we know that many components are connected to one another through the system bus, so it is important to assign a unique ID to each component. This ID is called the address of that component. When a computer component wants to communicate, this ID is called address of the component. When a computer communicated wants to communicate with another, it uses a few of the system lines are commonly known as the address bus. Not only the address is used to identify different components of a system, but it is also used to specify different memory locations within the main memory. For example, if is the CPU wants to the write some data at location 9872 in the main memory, it places the address of main memory and location, i.e. 9872, on the address bus. When the main memory sees its addresses on the addresses bus, it reads the data from the data bus and writes it to the specified location within the main memory. As the number of components connected to system bus increases, more components will be trying to use the system bus simultaneously. This will slow down the computer as components will have to wait longer to get access to the bus. To solve this problem, only the major components of the computer are connected to the system bus, and repairing components are connected to another bus, usually known as the expansion bus. The expansion bus is connected to the system bus. This is shown in the figure 5.7 below. The I unit is another very important component of a computer. Nowadays we have many important output devices like keyboard, mouse, disk, etc. All these devices are very different from one another in their organization. Also, these devices can handle different data transfer rates and support different data formats. Because of all these differences, it is impractical to connect all these devices directly to the system bus. It is not sensible to recover the CPU to control these devices directly, as they will take a lot of CPU time and will fill the system bus capacity. To avoid these difficulties, a special hardware compares unit is used. Only the I/O unit is connected to the bus and the processor, and All other devices are the connected to it has shown 5.8 below. The unit is responsible for keeping the track of states of different devices attached with it. It is also responsible for compensating the speed difference between the processor and the devices. There are two main ways of transferring data from the parallels into the computer. In this scheme, the processor issues the code to the devices. When the devices get ready, they generate an interput signal for the processor. On sensing this signal, the processor suspends all other processing and performs the operation.